All right, so today we're going to start with making the cable checkers. So this is what you're going to make. And I want to talk about like what this actually does because I think that will help. Like, how does a cable tester actually work? So I actually have one of these for everybody. Please take one and pass it around. I've made a little circuit diagram for this. And maybe you've seen these kind of things before, or maybe you haven't. But let me talk you through what's going on. So inside of this box, we're going to put a little 9-volt battery. Okay, that's just to have a little power to light up the LEDs. Okay, that's all it's for. And what happens is we take that 9 volts and we break it out here and put it through 4 different push-button momentary switches. And by default, these are called normally open switches, meaning when their normal or default state is not having the wires touch, right? So that the circuit is broken. So that's what's indicated here, is that there's that little plunger that you push down and it will connect the wires, okay? So when you push that button, what'll happen is, like on this red line, when you push the button, it'll take that voltage and it'll send it down this line, okay? And you're gonna connect the pins of each of these pins of each connector and thing to that particular switch, okay? And same thing for the blue one. You'll do XLR pin 2, NL4 1 minus, so on and so forth. Then the green, and then the orange. You can do whatever colors you want. These are just the colors that I put in the diagram. The colors just help you keep track, because there's going to be a lot of wires in here that you're going to need to keep track of, and you got to get them all in the right place or this doesn't work. So now then on the other set half of the connectors, you're going to wire those up together, but you'll have all the red ones will instead go here through a resistor and then an LED. Now what the resistor does is it soaks up a little bit of that voltage, okay? And you usually have to do that when you have LEDs, because an LED will use up a certain amount of that voltage, but it really doesn't know what to do with any leftover. So, if you measure the voltage going in compared to the voltage coming out of an LED, you'll see a lower voltage coming out of the LED of the other end, just because, it's using some of it. But it really doesn't have a mechanism for dealing with extra. And if you don't deal with the extra voltage that doesn't have a handle, what'll happen is the magic smoke will come out of that LED. Do you all know about magic smoke? So every electronic device is powered by magic smoke. And it's inserted into it in the factory when it's made. And it's the magic smoke that makes all of it work. And the way you know when you've really broken something is when you see the magic smoke come out. And you will see it. Like, it literally comes out sometimes. And when you see the little smoke, a little poof of smoke, just it'll whiff out of the thing, that's when you know it's really dead. You can't get it back, because the magic smoke came out, okay? So it's real. That's how you know. If the magic smoke stayed in there, there's a chance you might be able to get it working again. But once you see the magic smoke come out, you can't get it back in. It requires special tools that are only available at the factory to get the magic smoke back in. So the magic smoke will come out of the LED if you don't deal with that extra voltage. Okay, and then the LED is dead and you don't get to use it anymore. So what you do is you put that little resistor in there, which in this case is going to be a 220 ohm resistor, and that will soak up, the extra voltage that the LED doesn't know how to deal with. And then the LED doesn't, gets to hold on to its magic smoke. Okay? And then you connect that up to the other side of the battery. So there's this negative side of the battery that will connect all of these other things up to. So now imagine what happens when you put a cable between these 2 terminals, which represent the pins on the 2 connectors. Okay, so you've got XLR1 and XLR1 on each end of the cable checker. So on this side I got an XLR, and on this side I got an XLR. So if you put a cable between those 2 things, you are effectively jumping that one to that one, that one to that one, and that one to that one. And if you do that, you have completed the circuit. And so if the cable is good, then the circuit will be complete. And therefore, when you push this button, the electricity will be allowed to pass from here to there, through the resistor and through the LED, and the LED will light up. And that will tell you that pin 1 on that XLR is good, has a complete circuit. Okay? You push button 2, and that energy is allowed to go through pin 2 of the XLR, goes through the cable to the other side, to the other pin 2 of the other XLR, through the resistor, through the LED, LED lights up, connects up to the battery, you know that pin 2 is good. So on and so forth. You see how that works? It's a very simple little device. This is not a huge feat of electrical engineering here to make this little cable checker. It's literally just a continuity checker, just like your meter that you run. So this is electrically what you're going to do, okay? Now, this is the prototype that I built this summer when I was trying to figure out how to do this project. And I mostly got it right the first time, okay? There's one little thing that now that I've done it, I realize I should have done differently. And that is, I should have done the buttons and the LEDs on this side of the box for reasons that will become very apparent when I open the box. Okay? So let me show you what's going on inside of here. First of all, I almost had to like sit on this lid to get it closed. And now I'm going to open it. Here we go. Will he be able to get it closed again? That one. That one. And that one. Okay, here we go. Are you ready? Okay. So, I don't know if you can see it, but there's a little circuit board in the bottom there that I had to wire all those things up to. Well, do you think I soldered that while it was underneath all of these connectors and cables? No, I would not have been able to do that, right? I soldered it when it was sticking out up here. And then I had to fold it all up and tuck it in under there. It took me an hour to like jam it in under there to get it out of the way so that I could then close the lid. And I realized as I was sitting on this lid to squish it into place, I thought, oh, I should have put the buttons and the LED on the bottom of the box. And that way the circuit board could sit on top where I could solder it. And then all I got to do is just shut the lid on top of the circuit board. And I don't have to worry about squishing it all in, okay? So that's what I'm going to suggest that you do, is that you actually drill out the buttons and the LED holes on the bottom of the box. And you'll have a much easier time, both getting this all inside the box and getting the lid on, and it'll be a lot happier, okay? But you can see there's the little 9-volt battery, and on the back here, you've got the little LEDs, and I've got the resistors in line here, and I've heat shrinked around them just so that they don't short out. So we'll talk through all that. But then here's all the connectors. Now, I'll got started on a few of these connectors last week, but here's what you're gonna do. You're going to go get yourself one of each connector, and you're going to decide what colors of wire you want to use for each of the 4 circuits you're going to make. It doesn't matter what colors. You know, in fact, if you all do the same colors as my diagram, we'll run out of red wire. Okay? So, you know, you can exercise your creativity here and create whatever rainbow of colors is the most pleasant to you. Okay? You just have to decide, and you have to be consistent. So you decide what button 1 color is, and you decide what button 2 color is, what button 3 color is, what button 4 color is. You will need the most of button 1 and 2, because every connector uses circuit 1 and 2, and there's only one connector that uses circuit 4, and that's the NL4. Okay, so you will need the least of that color. So anyway, but what you're going to do is you're just going to go, I've got those little spools of, this is just called hookup wire. You're going to go and cut yourself off about little 5-inch lengths of it, of each color for each connector, and you just solder them up to the right pins based on that circuit diagram I gave you. This is really easy soldering because these are tiny little wires. It doesn't require a lot of solder, doesn't require a lot of time. You just heat it up, stick it on, and it's good. Okay, so this will be easy, but this is a lot of work. You got to do every single connector. So Alk has done the XLRs and the NL4s so far. Okay, but you got to do all of them. You solder up all the connectors. Okay, once you get them all soldered up, then you can put them into the box. Okay, so that's one of the tasks that needs to happen. The next task that needs to happen is you got to drill all the holes for the box. So here's one of the boxes. Okay, it's just, this is called a project box. I got it from bought it from a company called Polycase that makes all these different, you know, boxes for that you can use to build cool stuff with. And so I bought a bunch of these boxes. Now I have CAD'd out. Take one and pass it around. This is the hole pattern that I came up with to fit all the connectors into the box. Now, you can do it this way, or if you think you've got a better way that can get all those connectors in this box, including the 9-volt battery and the circuit board and the, you know, 2 miles of hookup wire that you got to like wind up and get in there, go for it. Like you don't have to do this layout of holes, but you only get one box. So if you drill the holes in the wrong place and realize everything doesn't fit, I don't know what you're going to do. Okay, so before you drill a hole, make super duper sure that hole is in the right place and that the thing that has to go in that hole is going to fit there. Okay? Yes, Abby. It is full scale. No, you don't. What you're going to do is you're going to just get your scissors out, you're going to cut this out and tape it to the side of the box, and then you're literally going to drill right where the X is. Okay? That drill bit can handle going through this little piece of paper. It's not going to care. I would suggest, especially when you do these big holes for the XLRs and the NL4s, do that big hole, but don't do the little holes until you actually slide the connector in there, because these big holes have a tendency to drift a little bit. It's a really big bit you're going to use, and it's really hard to keep it all steady. And so if you drill those small holes at the same time, they may not line up right with the connector. So do the big hole first, put the connector on there, and then get a little pencil or a Sharpie or something and mark where the actual screw holes are, and then drill those. Okay, that way you'll get them right. So this is the idea. I've tried to make this easy for you, so you don't have to do it this way though. If it would be really exciting for you to do what I did and look at this little empty box and get the handful of stuff that has to go in there, and if you want to figure out a different way of cramming it all in there, I'm sure there's probably 50 other ways to do it. And if that's exciting to you and you want to figure it all out, you want to like lay them all in there and figure out how they'd all fit, knock yourself out. But if that sounds like a completely boring or frustrating or mind-numbing activity, you may just use the thing that I made. That's totally fine. Whatever you want to do, okay? I will say that on the pattern for the switches and the LEDs, there is this little hole right there. Now that represents this little nub on the actual box. Now that, I think that's like where the injection mold happened or something. So I'm not saying you should drill a hole there. I'm just saying use that as a guide to line up the template so you know it's in the right place. Okay? Make sense? So we have the drill press over there. I got the As You Like It folks to clear a path to the drill press yesterday. So, but we only have the one drill press, so you can't all drill at the same time. But one person can drill at a time. And you can decide if you want to drill holes first, or solder connectors first, or solder some connectors and then drill a few holes and come back and solder some more connectors, whatever you want to do. But focus on the connectors first. And when you get all the connectors done, and you've got the holes drilled and everything, then I'll get you all back together again and show you what you have to do with the LEDs, because you got to add those resistors into there, and that's a little tricky. So I need to show you how to do that. So I'm not going to go there yet, because you have plenty of work to do, drilling holes and soldering up all those little hookup wires to the connectors. The other thing I want to do is, and you can use, if you've got a drill and you want to do this, is once you get all these wires on here, it's going to make your life a lot easier if you twist them together like this. And I usually get my drill and just like literally put the wires inside of the drill and go, and it spins them all together. That's much faster, but you know, if you want to do that with the drill press or something, you can, but you can also just twist them like this. And it's going to make, I think that looks nicer, but it also is just going to make things a little bit easier to manage when you start cramming all these connectors inside this box, okay? I've actually given you a very spacious box to cram all this stuff into. If you look at like that cable checker over there, yes, that one there, that's a smaller box, and it has more connectors in it. Like they've added MIDI connectors in there. So if you want to open that one up sometime and see what they had to do to pull that off, you can see. But you have, this is a palatial estate compared to, you know, what some of the other options were. So it's totally possible to cram all this in there. And as you can see, it's a really simple circuit that once you hook all this up is really useful. It can test any cable. The other cool thing about this, I want to point this out, the way this circuit design works is it allows you to test adapters. So imagine you had an XLR to 1/4 inch adapter. Well, if you wired that up right and you put that in there, it would complete the circuit from the XLR pin 1 to the 1/4 inch tip, and the XLR pin 2 to the 1/4 inch ring, and the XLR 3 to 1/4 inch sleeve. And that circuit would complete, wouldn't it? And it would light up. So it will allow you to test adapters. Isn't that cool?
Yeah.
Yes. Okay. This is cool. This is a cool. I think this is cool. Maybe you don't. But anyway, all right. Start building it. I'll get you the connectors and stuff.